My name is Anuj Nair. I'm a senior software engineer at Slack, concentrating on front-end performance and architecture. And today we're going to talk about how you can build real-world desktop apps using Electron. Specifically, we'll talk about what Electron is and why you might want to use it. Equally as important, why you might not want to use it. And then we'll take a little bit of a dive into how the Slack desktop app works, how the architecture has been set up, and any interesting things that we can think about there. So I want to start us off with a really simple question. What differentiates a web app from a desktop app? Now, a long time ago, back in the day, when Word and Excel were the only real ways to create documents and spreadsheets and so on, there was only one real way to share them after you had created them. And that's by taking them and putting them on a floppy disk, if we're going really far back, or a USB key, and then physically handing it to someone. And that was the norm for a long time. And the reason for that was because internet speeds were slow, and internet infrastructure just wasn't set up to allow us to communicate back and forth over the internet. But over time, those speeds have increased, and the limitations, if this catches up for us, the limitations which we once had are no more. All right, I'm going to head to this and do it here. Oh, there we go. Google eventually stepped up and said, we can put these desktop apps on the web, and we can fundamentally change how people interact with them. Now, they appreciated that they wouldn't be able to have all of the deep integrations with the operating system like Microsoft Office has, but they could enhance other features in really great new ways, things like collaborative editing or even version control for our documents. Things just haven't moved from the web to the desktop, though. Things have also moved from the desktop to the web. So I think it was last year, maybe the previous year before that, GitHub relaunched their GitHub desktop application, which essentially allows you to do a lot of things which weren't possible before through the normal web interface. Things like image diffing. It makes complete sense to have your local computer diff images rather than have the remote GitHub servers do that. We can keep those for collecting all of our commits and so on. Now, over time, the line which has made something a desktop-only app or a web-only app has blurred as the limitations of what stopped us crossing these boundaries have eventually disappeared. Once upon a time, desktop apps didn't have internet connections. And web apps, hey, they didn't even have sound and video, let alone graphical rendering capabilities or offline support. But now that is changing. The only real difference here is that web apps don't have full access to the operating system, and that's by design. Our browsers sandbox that functionality for us. And desktop apps aren't automatically cross-platform compatible because they've all been created with different architectures, different APIs, different languages. So as we've seen through some of the talks today, if I was to ask you to create a cross-browser compatible application, well, thanks to browser vendors, we don't have to worry about which platform we're creating our web app on. And thanks to tooling such as Babel.js, we don't even have to worry about the version of JavaScript we're running. We can simply write clean modern code, and Babel and all of those related tools will transpile those down to us to our necessary targets. But the story is slightly different if we were asked to create a cross-platform compatible application. Now, there's a lot of pre-planning to do beforehand to make sure we can achieve this, and there'll probably even be some unknowns which pop up unless you are a unicorn and are an expert in all three operating systems listed here. And the reason for that is because there are a lot more languages, a lot more APIs, different architectures. All of the operating systems have been created in different ways. Now, that's essentially what Electron is trying to solve. Electron takes Chromium, which is the open source part of Chrome, minus the Google-specific parts, and it combines it with Node.js, a cross-platform runtime, to create Electron. It's open source, and anyone can create cross-platform compatible apps using it. So let's consider what just 2 building blocks there brings us, some of the pros that Electron now has. Well, we've taken those however X many languages that we just had to consider and essentially boiled them down into 3. HTML, CSS, and JavaScript, our barrier to entry to create desktop apps has essentially disappeared. Now, we're not just limited to those 3 languages as well, and that's one of the powerful things about Electron. We can also write in some of the native languages as well and mix and match those different modules into our Electron application. Second point, thanks to the Node.js runtime, we can create apps for those 3 major operating systems simultaneously. We don't have to duplicate efforts anywhere or spin up new teams to create exactly the same thing over and over again. Thanks to Chromium, we don't have to worry about older browsers. We don't even have to polyfill for older browsers, because Chromium is usually up to date, has all of the latest features, and so we're essentially just developing for the latest browser renderer at all times. That's all of our dreams, right? Don't have to worry about anything else. Electron also bundles in crash reporting and code debugging. These are arguably some of the most important things that you need to add into your application, but probably some of the most dull to develop. They've been done over and over again. But Electron just bundles that in for us. And the final thing, and probably one of the most powerful parts, is you guys, the community that we have here. Anything that is published on NPM can be consumed by any of our Electron applications. There are some really interesting product pros to consider here as well. And this is one of the reasons why Slack uses Electron as well. The first thing, cohesive experience. Now, thanks to that one runtime with a single set of developers creating an application for 3 platforms, we can actually release all of those features simultaneously to all of our different users. Now, I'm going to use Slack as an example here. No matter what operating system you're running Slack on, you always get the same experience. So let's take Michaela's talk and say we introduce a new feature into Slack, VR messaging, right? You can type messages, sift through them, do whatever you have to do. But if I was a Mac user and I sent a VR message to someone on my team who was using Windows and they didn't have the updated features available, well, that's no good for them, right? Especially for something like Slack, which touts itself as a collaboration tool. Self-updating applications. This is probably something that we take for advantage as web developers. We can create new bundles and push our code to remote servers, and when the user hits our server, they will automatically download our new application. But that's not really the case for desktop apps. In the desktop world, users have to go and manually download and manually install those applications unless you've set it up in a way which it self-updates. Now, Electron has all of that built in for us, so we don't even have to worry about that. The final thing, and probably a hidden gem of Electron here, is that it has installers automatically available for it. Now, if you are creating an application and want to distribute it en masse, especially to larger companies, well, their IT teams aren't going to go around to 100,000 different computers and put your app individually on each one. They're going to want an automated way to do this and to manage those updates as well. And so Electron has packages for all of the 3 major operating systems to help you out there. Lots of companies are already using Electron to create very powerful apps. People like Discord, GitHub, I guess now Microsoft, Slack, all of them are using Electron to create amazing applications, which we use every day. VS Code is actually a really interesting one because it's an app created in Electron to potentially help you create Electron apps. So we've talked a lot about what Electron is and what the problem it's trying to solve. So how do we go about creating our own Electron application? This blew me away. It's literally 4 lines to set up here. We don't have to worry about any ops or deployments or AWS or droplets, whatever. 4 lines, and we're good to go. So the first thing is to initialize npm in an empty directory and agree to all of the default commands. The second one, install Electron locally. Third, create an empty index.js file. And finally, use that local version of Electron we just installed to run that index.js file. That's what the npx command there is doing. And what do we get? Well, hey, we get an empty desktop. But that's OK. That's expected. We haven't told Electron what we want to render. So how do we get Electron to render some content which we want to see? Well, for that, we're going to have to dive into the architecture of Electron. And it's completely based on Chromium. It's inventing no new things here. To start off with, we have a main process, which has very deep hooks into the operating system to allow you to open your app, close your app, hook into all of those APIs. And then for each tab or window that we want to open, we have to spin up what's called a new renderer process. Now, the reason for this is that the Chrome team was seeing on Chrome was that poor performance in one website was negatively affecting the performance and experience of all other sites. Now, that's not fair to the sites, especially those sites which really concentrate on performance and want to make their app as performant as possible. So by isolating each site into its own process, no site is going to be penalized for the poor performance of another one. So let's take this knowledge and let's add to our index.js file. I'm going to destructure app and browser window from Electron there. App and browser window are just the main and renderer process that we've been talking about. I'm going to create a global variable. I've called it win, and we'll get back to why it's a global variable in a second. Create a function, create window. This is essentially just going to instantiate a new renderer with some arguments or some properties that we're going to pass to it. And then finally, when the main process tells us it's ready, when the app is ready, we're going to run that function. Now, about that global variable, this is probably the one gotcha you're going to hit early on into Electron development, but it's not specific to Electron. It's a JavaScript thing. And you probably won't hit another one until you go really deep into its development. So the reason that we keep this variable global is because of the JavaScript garbage collection. So we want to keep a reference to that browser window at all times until the user decides they no longer need it. If we kept it as a local variable, the JavaScript garbage collector would clean that up and then would close down our window as well, which is not great, especially for, again, as an example of Slack, typing a message, and then suddenly the JavaScript garbage collector comes around and closes your app down. Definitely don't want that. All right, so let's now run this index.js file against Electron. Hey, we get a window, nothing in it, because we haven't told it to render anything yet. So back to our index.js file, one line here. Let's just render something from the index.html file in the same directory that we're currently in. And if we give index.html some really basic content, hey, what do you know? We get some content in Electron. We can even use this method, as the name suggests, to load a URL. So in this example here, I'm going to stick google.com into there. And if I now run Electron, I get Google in an Electron app. Great. So now I can pack this up, ship it off to the App Store, sell it, make some money. So at this point, either by loading a local file or by loading a remote URL, we're just doing what we do every day. We're using HTML to add content to our application, CSS to style it, and JavaScript to add functionality. This should be pretty familiar to most people in the room. We're essentially just developing a web app as usual, but we're creating it for the web. There's no real difference now, right? Well, let's reconsider our core building blocks of Electron, Chromium and Node.js. Chromium means that we have access to the Chrome dev tools in all of our Electron apps. And that's great because it's incredibly powerful. But Node.js means that we have access to all of Node's core modules, one of them being the file system. So in this example, I'm dynamically requiring the file system and then using it to read all files in the current directory I'm in. Now, this is incredibly powerful, but this is incredibly scary. Let's think back to our Google example. If Google had Node.js code on their homepage and I loaded it into my Electron app, well, they could potentially do whatever they wanted to my operating system. Now, browsers usually sandbox that type of functionality for us, but Electron is not a browser. It's a framework to allow you to create native applications, and there are inherent risks which come with that. So because of this, it's really important that we talk about security. Now, these 4 rules that I've listed here apply to general web development, but they're extremely important for Electron apps, especially if you're loading remote content. So number 1, only load secure content. It's 2018. Everything should be encrypted. Let's reduce the likelihood of a man-in-the-middle attack. Number 2, let's disable Node.js integrations which display remote content. You should never allow someone else to load remote node modules in your application. Only you as the developer should be able to choose which ones load. And so we'll go through how to do this in a secure way in a second. Number 3, let's use content security policy tags and sub-resource integrity checks to make sure that we are loading and running the JavaScript which we expect to load. This is a super simple implementation in the browser, but extremely powerful. And especially if you're using a bundler like Webpack, well, Slack has open sourced a few tools which can help you with this. Finally, and probably one of the most important, never trust external resources. Now, as web developers, we say that you should never trust user input or user output. You should always sanitize that kind of stuff. But we're going to take it a step further and say, just don't trust any external resources in general. Now, this is extremely important to something like the Slack desktop app. Maybe some of you know, maybe some of you don't, but most of the Slack desktop app actually loads remotely from slack.com. And this is so everyone who is using the desktop app can have exactly the same experience as everyone who is using the browser version. But by not trusting external resources, we can make sure that we sandbox that locally remote code away from the operating system. So just in case our code may be compromised, we're still protecting our users. So how do we use Node securely? Well, there is a way to disable Node for remote renderers, but still use it in very predefined ways. And we do this through the use of preload scripts. Now, preload scripts always have Node enabled, even if we explicitly set Node integration to false when creating the browser window instance. Now, for example, in this preload script at the bottom there, I've defined a very strict function which we can use in our Electron app to read files in the current directory, just like we had before. But the difference here is that my Electron app, when I run it, won't have access to the underlying require function or the Node implementation. So it's a little bit more secure there. So that's the basics of creating an Electron app in a secure way. And a lot of this information can be found online in tutorials as well. So I thought it would be really interesting to go through something which is not easily found online, how the Slack desktop app has been architected, and how we can use Electron and some other popular libraries to scale. Now, when we first started creating Slack, we very naively thought that we would be creating it for teams of 5 to 50 people. And oh, were we wrong. But that's OK. We started there, and this was an OK setup for us to begin with, what we've been talking about, having a main process and a renderer process. But as more users started using Slack, we shockingly found that this process didn't scale for us. For example, users were posting images and GIFs in one workspace, and then were switching workspaces, and we're seeing the performance of that workspace lag, which isn't a great user experience. So to help with this issue, we knew we would have to move each workspace into its own process, just like Chrome does with its tabs. But then came the UX and product question of, well, how do we allow users to switch between those different workspaces? It meant that we couldn't simply just drop content into each browser window, because then it leaves no space for us to add desktop-only UI to be able to switch between them. So the solution to this was to decouple the desktop UI rendering from the remote UI rendering and load workspaces into something called browser views. Now, browser views allow you to embed additional content into browser windows, but they themselves also work in their own process. You can kind of think of them like iframes when we're creating HTML. Create a page, you drop an iframe in it, and you can load another remote page. Now, this means that we can have the browser window load UI to allow us to switch between different workspaces, and then we can drop a workspace into each browser view for any of them that you have loaded. That way, when the user then switches between the different workspaces they want to see, we can just change which browser view is attached to the main browser window. This is also great because it keeps up our security processes. Each browser view, as I mentioned, is running in its own isolated context, and that means we can also disable Node integrations in there as well. It surprisingly means that the browser window here is actually the most powerful process in the Slack desktop app, not necessarily the main process, which people might expect, because the browser window has access to both Node to render content and the DOM, and the browser views only have access to the DOM to be able to drop that remote Slack code in there. So this is how it looks in the Slack app itself. Technically, the entire client that we're viewing here is in a browser window, and it has to be, because otherwise we'd be missing parts of the UI. But this part here is what we drop into a browser view and what we load remotely from slack.com. That left-hand part there with the workspace switcher is the only part which the desktop app itself renders. It's also really interesting to consider how Electron plays with other popular libraries that are out there and available to us. So let's talk about data. We use Redux to store all of our data, and we actually have a Redux store in each one of our browser views, which holds data very specific to the team that that browser view holds. And we have another Redux store in the browser window. And that essentially is our source of truth and acts as our main entry point into the app. So let's think of a couple of product examples where this setup really helps us out. The first one I'm going to talk about is unread notifications. So let's say you have 4 workspaces loaded in your sidebar. 3 of them are active, i.e. you can switch between them, and it switches as normal. There's no real lag behind that. But one of them is unloaded. Unloaded meaning that the Slack desktop app is smart enough to know which ones you use on a daily basis and which ones you don't. And so it will unload workspaces which it thinks you don't use as often to try and save some resources. But if it was to do that, and I was to receive an unread notification on that 3rd workspace up there, well, how would we notify the user about that? Now, if we were in the browser world, we wouldn't be able to do that. We wouldn't be able to push notifications or send any messages to a site which isn't loaded. You can't do that, right? But Electron is different. Electron is not a browser. And technically, those tabs on the left-hand side there are not actually tabs. They're just divs, which we've rendered to look like tabs, and we've made to function like tabs. And so that means that there's a little bit more flexibility in what we can do there. So if I now receive an unread notification on that 3rd workspace, well, we actually set up a very lightweight WebSocket connection in the browser window, which knows all of the workspaces which are loaded in your desktop app, and it receives messages about all of those different workspaces. So if it receives one for number 3 there, then we can simply render another div to look like a notification to make the user then go and click and see what kind of content they have waiting for them. The second interesting product feature where this setup is really helpful for us is for something like statuses. So we have an enterprise product called Grid, which essentially allows admins to break up monolithic companies into multiple workspaces, but still manage them all from a single source of truth. There's lots of other features, but not relevant for now. So let's say that I was in 3 workspaces, all under the same company. That's actually workspace 1, 2, and 4 there. That's our global PDE and social channel in Slack. And let's say I update my status in the social channel, or the social workspace, sorry, to say I'm going for lunch. Well, I'm technically part of the same company, so I'd probably want that status to be reflected in workspace 1 and 2 as well. But we don't want to keep firing off a ton of API requests. What happens if a company is split up into 100 workspaces? We'd be sending 100 requests for no reason. So the way that we do that is we actually have the workspace which you update your status in, dispatch an action, and that actually bubbles up to the browser window, and then it replays that action down to the necessary browser views, which might be interested in that status update, which are all under that same company. So these are a couple of ways that this setup has really helped us, how this Electron Redux setup as well has kind of helped us to scale a little bit more. What is next for Slack and Electron? So Electron provides a lot of APIs, which we can definitely take advantage of. And so Slack will probably be looking into how we can deeper integrate with the operating system. Things like with Explorer or the dock, or Cortana or Siri. There's lots of different things which we could potentially do, which we'll probably start exploring soon. We also get some tweets about how Slack can occasionally spike in memory, especially if your workspace is one which loads a lot of GIFs or custom emoji. And so we've started solving these problems on the remote code on slack.com, and it means we'll be able to start consolidating those multiple browser views into one. All of these improvements will effectively make the Slack desktop app a much faster and more pleasant experience to have. Final question for you. Should you use Electron? Well, as always, it really just depends. If you want to create a cross-platform compatible application, then yes, you should definitely consider Electron. It has a lot of the hard parts made easy, and it bundles in a lot of things which would be incredibly useful and very familiar to us as web developers. But you should truly think about what value you would be bringing to your users if you do create a desktop app. There's no point in creating one just for the sake of having one. Because with it comes trade-offs. Things like you have to always make sure that you're up to date with your security best practices, and things like making sure that you're always considerate about how much memory your application is using. So that's all I have time for. If you have any questions, then please come and find me. Otherwise, hope you guys all enjoy the evening and your rest of the time in Barcelona. Thank you.